In this video, let's learn how to solve or add this part radical equation. This is an addition of radical equation. I want to see how we'll do it using factorization method. Don't forget to give this video a thumbs up. Also subscribe to my channel for more content. That means a lot to me. Thanks so much. Now let's look at how we can simplify this. To simplify this, I can simply say all this is equal to y. That way, if I find the value of y, I find the addition of these two radicals. Great. Now, how do I do that? The first point I want to think about is to bear in mind or to assume that a is equal to the first radical, which is the cube root of 2 plus root 5. And I'll assume that my b is equal to the second radical, which is the cube root of 2 minus the square root of 5. So if I have that, that simply means that I can determine and I'll decide that my y is equal to a plus b. So that tells me if I can simplify this, I'll get the value of the addition of those two radicals. Now let's get started. I'm going to look at these two radicals and simplify them. To simplify them, let me take the cube of both sides, and this will be equal to a plus b cube. Now, if I expand this other side, the right hand side of the equation, that will give me a to the power of 3, right? Plus 3a squared multiplied by b plus 3ab squared plus b cubed. Great. So having done this, all I have to do is to simplify. So I have my y to the power of 3 to be equal to, this will become a to the power of 3 plus b to the power of 3, right? And since 3ab is common here, this will become 3ab, right? Multiplied by a plus b. Great. So I've simplified that. And recall that from my initial expression, a plus b is equal to y. So this can simply give me my y to the power of 3 equal to a to the power of 3 plus b to the power of 3 plus 3ab multiplied by y. So the only task I have here, and also recall that I already know what my a is because my a is the two different radicals. So I can simplify that. But then what is the value of my ab? My ab can simply be the multiplication of those two radicals, which is 2 plus root 5, right? Multiplied by the cube root of 2 minus root 5. So if I multiply these two expressions, I should be able to get my AB. So if I multiply this, this will be equal to, both of them are carrying cube root. So this will be the cube root of 2 plus square root of 5, and then 2 minus the square root of 5. So this expression will now give me all the cube root of this multiplied by this is 4 minus 2 root 5 plus 2 root 5, and in sword, you know, root times root will give us the value, which is 5. So if you simplify this, we're going to have the total cube root of 4, while this goes 4 minus 5, and 4 minus 5 is equal to the square root of the cube root of -1, and the cube root of -1 is simply -1. So our AB is equal to -1. So we've gotten the value of our AB. So that expression can now give us y to the power of 3 equal to a to the power of 3 plus b to the power of 3 plus 3 multiplied by -1 multiplied by y. So this is going to give us y to the power of 3 equal to a to the power of 3 plus b to the power of 3 minus 3 what? Y. Great. So now let's simplify this in order to get the value of a cube plus b cube. So this will give us y cube equal to, this whole thing will give us what? The cube root of 2 plus the square root of 5, right? All cube plus this whole thing will give us the cube root of 2 minus the square root of 5 all cube minus 3 what? 3y. Great. So if we simplify this, this will simply clear this, and this will simply clear this, and then we'll have our y to the power of 3 to be equal to, this will be 2 plus root 5, right? 2 plus root 5 plus 2 minus root 5 minus 3y. So that expression will now give us a y to the power of 3 to be equal to, recall that this will simply what? Clear this, and we'll have this to be what? 4 minus 3 what? 3y. So our y to the power of 3 is equal to 4 minus 3y. This looks like a perfect equation. So we're going to bring it together. We're going to have this to become y to the power of 3 plus 3y minus 4, and this will be equal to 0. So if we factorize this expression, we're going to find the value of y, which is the result to the addition of those two radicals. So let's add. If we simplify this, this will give us y to the power of 3, y this will become minus y plus 4y, right? Minus 4, and this will be equal to 0. So y is common over here. We'll have this to become y squared, right? Minus 1, right? And this will be plus 4, and this will be y minus 1, y this is equal to 0. Great. So having done this, you come to see that this is a perfect square, so it can be expanded. So we'll have y, we'll have this to become y plus 1, and then we'll have y minus 1 plus 4 multiplied by y minus 1, and this will be equal to 0. So in all these, y minus 1 and y minus 1 is common. So we're going to bring out 1y minus 1 and all this. Y minus 1 divided by all this will give us y multiplied by y plus 1, right? While all this divided by y minus 1 will simply give us plus 4, and all this will be equal to 0. And this is the zero product law. So if we have this, we'll have two cases. The first case, y minus 1 will be equal to 0. And in the second case, y squared That's what that will give us, plus our y plus 4 will be equal to 0. So if we simplify this, this will simply make our y to be equal to 1, which is the first solution to the value of y to that radical addition. So the addition of those two radicals can simply give us 1 in this aspect. While in the other aspect, we're going to find the value of y using quadratic formula. If we compare this, we'll have this to become a will become 1, b will be what? 1, and then c will be equal to 4. So if we solve this expression, the value of our y will be equal to negative b using the quadratic formula minus plus or minus the square root of b squared minus 4ac divided by 2a. So that will give us y equal to negative b plus or minus square root of 1 square, which is minus 4 multiplied by 1 multiplied by 4, all divided by 2 multiplied by 1. Now recall that this is going to be negative what? 1. So that value of y will now be equal to, our y will be equal to negative 1 plus or minus the square root of 1 minus, this is going to give us 16 divided by 2, right? So we'll have our y to be equal to negative 1 plus or minus the square root of negative 15 divided by 2. So our y will be equal to negative 1 plus or minus square root of 15 multiplied by square root of negative 1, all divided by 2. And the square root of negative 1 is equal to imaginary. So this is going to give us our y to be equal to negative 1 plus or minus square root of 15 imaginary divided by 2. So the whole values of y, we're going to have our y to be equal to 1, which is the original value. Our y can also be equal to negative 1 plus the square root of 15 imaginary divided by 2. And the last value or last solution for the value of y can be equal to negative 1 minus the square root of 15 imaginary divided by 2. These are the whole solution for the value of y given to us in this expression. So you see, if we add those two radicals, we are going to have this solution to become this. So the sum of those two radicals, which is the square root of the cube root of 2 plus the square root of 5 plus the cube root of 2 plus or minus the square root of 5 is simply equal to 1, which is the only real solution to that expression. So I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.